Today we're going to continue with section 12.1 on our one-way ANOVA, and we're going to start with an example. This example comes from our textbook. Take a minute and read the example. So when collecting the data, the goal was to examine the relationship between the number of Facebook friends and the user's perceived social attractiveness. So what they've done is they've summarized the number of friends and they have groupings. We have a sample size. We have X bar for each of the groups and the sample standard deviation. So the first thing that we want to do is we want to look at the data individually. So they've made box plots for each different distribution. So people who have about 102 friends, they've made a box plot here. They've done the same with all the other groupings, 302, 502, 702, and 902. And this kind of gives you an idea if they are normal, and we can see these are the same at 502 and 702. They look fairly close. Maybe at 902 as well. I think 102 looks a little bit different than the rest. But basically, if we then look at the histograms, all 5 appear to be normal. So again, we want to examine the individual data before we move forward with the ANOVA process. So we have 5 different groups, each with a different number of Facebook friends. Sample sizes do not have to be the same. Does this sample meet the assumptions of the ANOVA? You don't have to rewrite all this. I'm just recalling from yesterday, but these are the assumptions that should be met. So we do have 5 independent, simple random samples, one from each of the different populations. We've examined their data, and each has a normal distribution. However, we don't know what the population mean is. All the populations are assumed to have the same standard deviation, and again, we don't know what that is. But based on our calculations for each sample, we do have an X bar to represent mu, and they are a little bit off. And then we have our sample standard deviation showing that they're not exactly the same. But if you compare the sample standard deviations, we said yesterday, if you take the smallest sample standard deviation and square it, and it's still less than the largest standard deviation, it is safe to assume that they're close enough so that we can run the ANOVA process. Now that we know that the assumptions are met, we're going to go ahead and calculate the pooled standard deviation. This is on the back page of your reference card. So looking at the chart, this is the formula for variance pooled. In the first line in the numerator, it's group number 1 sample size n minus 1, and then times its variance. And then in the next grouping, 33 is group 2, so minus 1 there, times its variance. We're going to continue to do that for each of the 5 groupings in the numerator. And then in the denominator, we're taking 1 off of each grouping, which will end up being our degrees of freedom. So we're going to simplify these calculations a little more. So I've done the subtraction and the squaring. If I have any mistakes, make sure you let me know. And then combining everything in the numerator and the denominator gives me a pooled variance of 1.20041. We do want the standard deviation, so one more step. We're going to square root both sides, and there's my pooled sample standard deviation. So our first assignment is problem 12.12. And we're just calculating the pooled standard deviation, which we just did. Now we want to build our ANOVA table to match the groups. So when we build the ANOVA table, we're looking at the different types of variation that might be present in the model. This is what we've been using now since chapter 10. So the data represents the total variation. The fit is now the variation between the groups, and the residual represents the variation within the group itself. We're going to modify this a little bit. So in the table, now we'll have sum of the squares total. We're going to have sum of the squares for the group. So instead of being sum of the squares model, it's now sum of the squares group, and we still have sum of the squares error. When we compare several different means, we want to use the F statistic. So it's the same ratio as before, but now we'll use the mean square of the group divided by the mean square error. Degrees of freedom are also associated with each of these pieces in the table. So degrees of freedom total is I minus 1. I represents the number of groups that you're working with. In our Facebook model, we had 5 groups. Degrees of freedom for error, capital N is the total number of observations. So you would add up all the observations in all of your groups for a grand total. And then minus capital I, which is our number of groups. And degrees of freedom total is always N minus 1. Again, capital N meaning all the observations minus 1. So when we organize our values inside this ANOVA table, we can analyze where the variation comes from. When we build the ANOVA table, remember the mean square error, when that's square rooted, will give us our sample standard deviation, and it is pooled. And then our coefficient of determination, R squared, is based on the ratio of sum of the squares groups divided by the sum of the squares total. And this will tell us how much of the variation is due to the model. We're going to further our example with the Facebook friends, and we're going to complete an ANOVA table. The sum of the squares error and the sum of the squares for the group were provided. I just plucked these pieces so that we could build the table, but we can always run the ANOVA on our iPad if we had all the individual data. So I'm going to start with my sources. So now we have groups, error, and total. And I'm going to fill in the 2 pieces that I do know that were provided in the example. We're going to go through now and fill in our degrees of freedom. So we had 5 groups of Facebook friends. So the degrees of freedom for groups is N, or I minus 1. So it's 4. Error is N minus I. So we had 129 degrees of freedom. We actually saw that in the denominator of our pooled standard deviation calculation. And a grand total of 133. So that means we really had 134 observations. I'm going to go ahead and total my sum of squares. When we calculate the mean square for the group, we're going to take the sum of the squares and divide it by degrees of freedom. So 19.89 divided by 4. We're going to do the same with the sum of the squares for the error divided by 129. The F statistic is the division of these 2 pieces. And then calculating the p-value can be done with your iPad. And that would show a significant value. So what I did is I used the wrench, statistics, distribution, and we're doing F, CDF. The upper bound is our F statistic. The degrees of freedom for the numerator and the denominator come directly from the table. We also have to calculate the value of S, our sample standard deviation. We've actually already done that, but it would be the square root of MSE, so 1.20052. And because we had done the pooled sample standard deviation, we know it's 1.09568. We also need to calculate the coefficient of determination, R squared. This ratio is going to be the sum of the squares for the group, 19.89. divided by the sum of the squares total, which is 174.757. And on the iPad, that result will give me 0.113815. So this is saying that only 11.4% of the variation is coming from the model. We're also going to complete problem 1220. We're only going to do parts A and B. If you have any trouble with the notes or doing the homework, please make sure you get in touch with me. Have a great day.